today is the review day for the test. Test is Monday. I don't see any faces that I don't recognize, so I assume you all know that. So you were supposed to come today prepared with questions over the review exam that I posted out there. Before we start on that, are there any last minute questions over the homework that's due tonight, which is section 10.1, or anything else that is just really bugging you about making out your cheat sheet or whatever? Chelsea?
What chapters does this test cover?
That's a good question. This test covers from chapter 7 up through chapter 9 plus the one section from chapter 10. And chapter 7 is the central limit theorem, sampling distribution kind of stuff. An awful lot of that gets kind of tested along the way on chapter 8 and 9 questions. But since you brought that up, I noticed that I did not have a question on my review exam that directly got at the central limit theorem. But I will have on the exam. So here's a supplemental problem to your review exam. So let's do this one first, and then we'll start in on the review exam. It says if pulse has a mean, and this is population mean, of 72, and a population standard deviation of 12, what's the probability that the mean of a sample of 5 pulses will be greater than 90? Okay, it's not probability that an individual is greater than 90, but the probability that a sample mean of 5 people will be greater than 90. Okay. How the heck are you going to work this problem? It is a probability problem. It's not a hypothesis test. It's not a confidence interval. It's not a sample size calculation. You have to recognize, oh, this is a probability problem.
Would it have something to do with 99999 at the end?
Yep.
Okay. Is it like a binom PDF?
It's not binom.
Normal, sorry.
Right. This will be a normal CDF problem. How do you know that? I actually forgot, but what do we know about the distribution of pulses? That they're reasonably normal bell-shaped, right? And so I have a small sample of size 5, and we know that sample means x bar will be approximately normal as long as n is greater than or equal to 30, unless the individual data is already normally distributed, then you don't have that requirement about getting to 30. So even though this one's 5, since we know pulses are normally distributed, this probability written out in symbols, it says probability that the mean of a sample, well that's x bar, is greater than 90. In order to figure that probability, you need to know, well, what's the distribution of x bar? And chapter 7 tells us that by the central limit theorem, x bar will have an approximately normal distribution with a certain mean and a certain standard error. So this is going to be a normal CDF problem. And now you just have to figure out what to fill in. In the normal CDF function, do you remember what you enter?
Left, right.
Left, right, mean, and standard deviation, although when it's a sample mean problem, we call it standard error. So we're going to enter left, right, mean, and standard error. The left is 90, and the right is infinity, so a bunch of 9s. And then the mean is 72, and the standard error,
12.
not 12. 12 over
5.
square root
At
of 5. 12 over square root of 5. And if you're sitting there thinking, where in the heck did they pull that out of? That's from the central limit theorem. That's the standard error of a mean, right? Standard deviation divided by the square root of the sample size. Most common mistake on this problem is to just put 12 there. But it's not 12, it's 12 divided by square root of the sample size. Okay. And in your calculator, you can actually type that in, 12 divided by square root of 5, right into the normal CDF function and not have to do an intermediate calculation. Okay, has anybody got that yet? And actually, I keep forgetting, but I have one up here. So I could type it all out, but I won't take the time right now. So go ahead and tell me. You're sitting there done. What'd you get? 3.98 times 10 to the negative 4. Now, does that make sense? Does that seem like it is in the ballpark? Always check your answers, just mentally. Does that seem about right? That's a really small probability. Does that make sense that it would be really small? Yeah, it's fairly unlikely for a single person to have a heart rate above 90. So to get an average of 5 people above 90, that's going to be really unlikely. And remember, we had, I think, one sample like that in our data set. Okay? Question?
Are you going to post this online?
This question or this?
This question and solution so we can look at it?
Yeah, what I'll do, if somebody reminds me, is I will put this in the solutions that I'm going to post right after this class. Actually, I've got 2 back-to-back meetings right after this class, so sometime this afternoon, I'll post the solutions, and I will add this to it. But if I forget this part, as soon as you download it and you look for it, say, hey, you forgot to put that one question in there, and then I'll replace it. Okay. So that's the supplemental question. Are you ready for that? Remember on the online homework and the practice problems at the end of the section, there was a question about Jan's all-you-can-eat restaurant. That was a problem like this, right? A central limit theorem type problem. What's the probability that the mean of all the people that come in that day is above, her expenses or whatever? Okay, now to the practice test that I posted. Do you need me to turn this light off so you can see that better?
Please.
What? Please? Okay. So you're supposed to come prepared with questions. I may not have time to do them all, so where do you want to start?
8.
8? 7? I'll take the low bid. Anybody need one before number 7? A couple of these we kind of already did in class the other day. Oh, this is a tough one. Yeah. This was almost above and beyond the Call of Duty, but it's a really good problem to reinforce the ideas of how confidence intervals relate. It says the width of a confidence interval estimate for proportion will be, and then there's 5 choices, and you have to figure out which of those 5 is correct. So we're just going to take them one at a time and say, does this sound right? So the first one, I'm going to zoom that up just a little bit. The first one, well, when I zoomed it, I lost where I was. There we go. So now it's down here. First one says, the width of a confidence interval estimate for proportion will be wider for 90% confidence than for 95% confidence. Is that a true statement? No, it goes the other way around. To be more confident that I've contained the true population proportion, I need to do what to my interval? Make it bigger. So smaller confidence has smaller intervals, bigger confidence, bigger intervals. So that's false. B says narrower for a sample of size 50 than for a sample of size 100. That's right, Morgan. False. Why?
The more samples you get, the narrower it is.
Exactly. The bigger the sample size, the smaller your standard error, the smaller your margin of error, and therefore the narrower the interval. So bigger samples let you be more precise. So that one's false. C says wider when the sample proportion is 0.95 than when the sample proportion is 0.55. Huh? Well, what dictates the width of an interval for a fixed confidence level? It's the margin of error, right? The margin of error has a critical value times a standard error. So let's think about that standard error. The standard error of p hat is p hat times 1 minus p hat over n. So they give us two different competing p hats, a 0.95 and a 0.55. Whichever one of those gives me a bigger standard error is going to give me a wider confidence interval. If my standard error is bigger, then my margin of error is bigger. Right? So it does not give us a sample size, but we'll figure for a fixed sample size. So let's make this a 100 for sample size. Put in the 0.95. And what do you get? Let me do it for me on your calculator. Somebody got it? I hear lots of buttons clicking.
0.022.
0.022 for that first one? Okay. Now do this one. You can do second function enter, it'll pull up the last thing you did, then you go over to the 9.5s and change them into 5.5. 0.05. Which one gives a bigger standard error? This one's bigger standard error. So the confidence interval will be wider for this one than for this one. Is that what it says? It says wider when it's 0.95, so that's false.
So the larger the standard error, what? Say that again?
The larger the standard error, the wider the confidence interval. Because standard error leads directly to margin of error. Now, this relates back to that concept of the sample size formula. And remember we said if you don't have a good estimate for the proportion, what do you plug in? 0.5. And how come?
Kind of in the middle of the screen.
It's in the middle and it maximizes the sample size. That's the biggest possible value for p hat times 1 minus p hat. So near 0.5 will have bigger value than far away from 0.5. And you can see that right here. This standard error is more than double what it is if you're further away from 0.5. Right? So then the next one says narrower when the sample proportion is 0.1 than when the sample proportion is 0.45. Now you ought to be able to answer that without doing any calculations. Which one, 0.1 for p hat or 0.45 for p hat, will give you the bigger standard error? 0.45 will be bigger because it's closer to that middle number. Right? So narrower when it's 0.1 than when it's 0.45, that's true. So that's going to be the right answer. So we don't even need to go to E, except for, I want to, narrowest when the sample proportion is 0.5. Well, we just kind of proved, no, that's false. How would I make that sentence a true sentence?
It's widest.
Widest when the sample proportion is 0.5. Okay? Okay, now that problem's kind of above and beyond the call of duty for an exam because you have to check each one of those 5 different things and they each take quite a while to do. That would be a lengthy problem on an actual test. I might pick one of those things and say true, false. Okay, next question. Number 8, okay. The Wechsler IQ test is designed to have a mean of 100 and a standard deviation of 15 for the population of normal adults. Find the sample size necessary to estimate the mean IQ of statistics students. if we want to be 90% confident that our sample mean is within 3 IQ points of the true mean. Okay? Anytime you read a paragraph like that, you should start asking yourself questions. Okay? First of all, what kind of a problem is this? Is this a probability problem? Is it a hypothesis test? Confidence interval? Sample size calculation? What is it? It's a sample size calculation. Because it says, find the sample size. I can guarantee you that at least one person, probably one person per class, will take off trying to do a confidence interval on this. Right? It doesn't say to do a confidence interval, so don't do it. People get so into that, I can do confidence intervals all over the place, so I'm going to do one. Don't do that. Once you know what kind of a problem it is, what's the next question you should ask yourself? Is it means or proportions? Which is this? Give you a hint. Which of those two words does it use all over the place in the reading? Means. And that's usually how you tell. You know, it says means, so it's a means problem. And it says, you know, like, of the true mean. It's got mean all over in there. So, then you go to your cheat sheet under means and you look for sample size formula. And right by that, it should have a little formula written there. And read that to me, Amy, because I know you have it on yours.
Z squared.
They were just in my office with the cheat sheet. Okay. N is z squared
Times S
times s squared
over
over
margin of error.
the margin of error squared, which I'm just going to call m, margin of error. So now all we need to do is figure out what those three values are, plug them in, and do the calculation. So the first one is z. What does z represent? That's the z critical value needed for whatever confidence level. They tell us to do 90% confidence, so what would z be? 1.645. And if you can't memorize those z critical values, then write them in the corner of the cheat sheet. Say for 90% confidence, z would be 1.645.
Are those in the book?
They are in the book. They're in the table. They're at the bottom of the T-table. It's actually the easiest place to get them. And I will have copies of the T-table for you.
Oh, okay, because I know the test says, looking at the T-table, I'm like, what is the T-table?
Yeah, the T-table's at the back of the book, and at the bottom line of the T-table is infinite degrees of freedom, which are the z critical values.
Okay.
Okay? So that's the easiest place. But your calculator will do them also with the inverse norm function. But easiest is just write them in the corner of your cheat sheet, and then you don't have to measure. You just look up, okay, that's... All right, so that's z. Now what's s? Standard deviation. And I use s, not sigma, just to emphasize it's an estimate, and they should have given us an estimate for standard deviation.
Within 3 standard deviations?
That's not standard deviation.
IQ point, sorry.
It's 15. It says standard deviation of 15 for the population of. So 15 goes in there, and then it's squared. On the bottom is the margin of error. That's the 3. It says we want to be 90% confident that our sample mean is within 3 IQ points of the true mean. In other words, we want to be in error by no more than 3. That's the definition of margin of error. Right? So I have a 3 on the bottom, and it's squared. All right, so do that math for me. 67.65. Okay? And it's number of people, so we need to round to the nearest whole number. So 68. So n is 68. There's your answer. Okay? Next question.
I got the first part of number 9, but I don't have B on number
You don't have B?
9.
Okay. Let
Can we
me,
do all of it?
Yeah, we could do all of it.
okay. Is everybody done with this? Can I erase it? Now I'll just leave this on the board and then kind of write around it. Actually, let me scroll it up to the top there a little bit. Okay, in the general U.S. population, it's been reported that 25% of adults smoke. In a recent survey of college students, there were 65 out of 505 subjects that said they smoked. Construct a 99% confidence interval, blah, 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 blah. What are they asking us to do? A confidence interval. So the next question is, means or proportions? It's proportions. How do I know? Because they use the word proportion right there. Also, they're talking about percentages. It's a categorical variable. Yes, no, they smoke. Means problems must be quantitative variables. So this is not going to be a means problem. Usually they'll use the word proportion, but it's not a guarantee they'll use the word proportion. So it's a proportions problem, confidence interval. What's the next question you have to ask yourself?
Do I go on my calculator?
Not yet.
Oh, assumptions?
Is it one sample or two samples?
Oh.
And this one is one sample. They talk about a recent survey of 505 subjects. They don't say, and then in a similar study at somewhere else, and give you two different samples. So there's only one sample here. So this is a one sample proportions confidence interval. Now you should be able to look at your cheat sheet and have it tell you what you're going to do on your calculator. One prop z int, right? So this is a one sample proportions. So one prop z int. So I'm going to pull up the calculator thing here and press the stat button, go to test, and go down to one prop z int. And press enter. Now I can't see the numbers because I pulled this up, but you can just read it to me. It wants to know what x is. So what is x? It's the number of successes, and it says there were 65 out of 505. So that number is going to be 65, and n is going to be the 505. What level of confidence did they ask for? 99. So I need to change that to 0.99, and then press calculate. So there's the confidence interval, 0.09 to 0.167. I'm just keeping a couple of places of accuracy here, but 0.09 to 0.167. Okay? So, coming back to the exam question, provide the correct interpretation of that interval.
We're 99% confident that the true population proportion of college students who smoke is in that interval.
Perfect. I wouldn't change a single word of what she said. What she said was, we are 95% confident that the, 99% confident that the true proportion of college students who smoke is somewhere in that interval. Okay? And that will get you full credit. Does the interval, and I've got my interval written over the top of it, but does the interval provide sufficient evidence to conclude the proportion of college students who smoke is different than 0.25? Explain why or why not. Jory, you say yes?
Yes, because 25% is not within that interval.
Exactly. 0.25, which is 25% as a proportion, is not in the interval. The interval stops at 16.7%, 0.167. Therefore, 0.25 is not plausible. So yes, it does provide sufficient evidence because it excludes 0.25. Okay, part C. What was the margin of error for the interval in part A? The margin of error is the standard error times the critical value. We have a standard error of 0.1287. Well, minus 0.1287. Where the heck did I get that number? Well, I didn't.
65 out of 10.
It's 65 out of 505. And the calculator tells us, it gives us p hat equal 0.1287. Right? So I rounded it to 4 places and I stuck it in here. Right? But that's just p hat. So you got that number?
0.038.
038. Give me one more decimal place.
3.
83, are you sure it's not 84?
Yeah.
Oh, yeah. Now, did you already do margin of error? Because this is standard error.
Oh, no.
Did you multiply by?
Yeah, that was multiplied by 2.572.
Okay, there's the difference. I knew that number, but I wasn't recognizing that number.
0.0149.
How much?
0.0149.
0.0149. Now to get the margin of error, we multiply by the z critical value, which for 95% confidence is 2.576.
99.
What did I say?
95.
Yeah, for 99% confidence. I'm trying to go too fast. It's 2.576, and then multiply by that number, 0.0149, and then what do you get?
0.0384.
0.0384, and that's why I asked you if it was a 4 a minute ago. I remembered that. But you had an 03 because I think you used a slightly different number there, maybe.
Oh. Yeah, I have a 2 instead of 6 for some reason.
Yeah, it should be a 6.
Wrong my cheat sheet then. Thank you.
Okay, so there's the margin of error. That answers that question. Now, did anybody do it a different way that's a whole bunch easier? Carly, what'd you do?
No, I did that.
You did that? Anybody else? How about this? You got the confidence interval, upper bound of the confidence interval is 0.1671.
Plus.
Where's the
minus.
center of that? Yeah, it's p hat plus minus margin of error, right? So the p hat is 0.1287. That's got to be in the center of the interval. So 0.1671 minus 0.1287. So this is upper bound minus p hat. That should give you the same 0.0384. Okay? So if you've already computed the interval, then you can get the margin of error just by doing the subtraction. You cannot get the standard error that way. You'd have to back out of this multiplication, so then it's easier just to bail out and use the formula. Okay? Part D, this is a long problem. Part D says, suppose some researchers want to repeat this study in a similar population at another university, but they require a margin of error of only 4%. What size sample would they need to have? What kind of a problem is this? It's a sample size calculation, and we're doing a proportions problem. So you need your sample size for proportions. N equal
Z squared.
Z squared,
Times P hat.
P hat,
1 minus P hat.
minus P hat over
Margin of error squared.
margin of error squared. Okay? Now, before we do it, think in your mind, ballpark idea. How does their margin of error compare to the one that we just computed? It's a little bit bigger. Ours was 3.8%. Theirs is a little bit bigger. So they're going to need a bigger sample or a smaller sample? Smaller. When we get done, we better have an answer that's smaller than 505. But not a whole lot smaller. So don't go down to 4, whatever, but smaller than 505, but so probably 400 and some. All right, let's start plugging in numbers. It doesn't say, and this is just my mistake, it does not say what confidence level to use. But if they're repeating our study, then we'll just use 99% confidence. So our Z critical value is the 2.576, and that's squared. If they're trying to repeat our study, they would probably use our p hat as their estimate of what theirs is going to be. So put in 0.1287 for p hat. Divide by the margin of error. Now what do I have to do? Do I put 4 on the bottom? 0.04. Don't forget to change it to a proportion if it's written as a percent. If you make that mistake, you'll get some really nonsense answer like 1 or 0, some bizarre thing. Okay? Now, has anybody computed that?
465.
465? Is that already rounded?
Yeah, 0.06.
So 0.06 on the end of that, so n is 465. Does that meet with what we thought it ought to be close? Yeah, that's in the ballpark, so you can be pretty comfortable that, yeah, I got that problem right, and go on to the next one. Okay? That was problem 9. How about problem 10? Anybody need to see that one? Okay. Problem 10 says, in a local factory they produce breakfast cereals. The printed net weight on the boxes is 18 ounces. The actual weights of individual boxes are reasonably normally distributed, and the company wants the true mean weight to be slightly larger than 18. Remember, this should remind you of what problem we did in class. The wine bottle problem, right? Net contents of the package. So that they can have a high level of confidence that any randomly selected box will have at least 18 ounces in it. They take a random sample of 20 boxes from the line on a given day and compute the sample mean to be 18.6 and the sample standard deviation to be 2. Use a statistical hypothesis test to determine if there's sufficient evidence from this sample to conclude that the true mean of all boxes produced is indeed greater than 18 ounces. Show all 5 steps. Okay? So, step number 1. What's the first step of hypothesis testing?
Check the assumptions.
Check the assumptions. What are the assumptions? There's 2 of them.
Random sample.
Random sample. Is that met?
Yes.
Yes, it's met. It says so. It says a random sample of 20 boxes. Okay? Assumption number 2.
At least 15 successes and 15 failures.
Is that right?
Or 15 failures.
Sample size of 30 or normal distribution.
I forgot to do what I say to always do first. All right, again, I'm trying to hurry. What kind of problem is this?
Means.
The means problem. Hypothesis test. It's a hypothesis test for means. So on your cheat sheet, you should say, if it's a hypothesis test for means, here's the assumptions I'm supposed to check. Here's the, and then step number 3, I'm supposed to use this on my calculator. Right? What are the assumptions for a means problem? It's not 15 successes, 15 failures.
At least 30.
At least 30, or
Normal distribution.
a normal distribution. We don't have 30, do we? We've only got 20. But, so it's either normal data or n greater than or equal to 30. The n greater than or equal to 30 is not met, but this is met. So assumptions are met for this problem. Step number 2 is to define the hypotheses using correct notation. Okay, we need a null hypothesis.
And equals 0.
I don't want to see this. What's wrong with that? There's no parameter in there,
X bar,
right?
I mean,
You're scaring me.
P's.
She said X bar.
Mm.
What's wrong with that?
X bar is 18.6.
We don't have to test anything about X bar because we can see it.
Oh.
It's 18.6. What we don't know is what mu is. So we have to test to see, we have to make inference about mu. So it's going to be mu. For a means problem, it's mu. For a proportions problem, it would be P. Right? So mu equal, and what is it that we're hypothesizing?
18.
They want us to see if it's greater than 18, so the null would be it's not, so it's equal to 18. I heard somebody else a minute ago say 0, but we're not testing to see if it's 0. I mean, if you're putting 0 cereal in the box, something's wrong, right? So always think about the numbers. So the alternative, greater than 18, because they say test to see if the true mean is indeed greater than 18. So it's a one-tailed test. Okay, now step number 3. Step number 3 for me is the easy one. It's just tell where on the calculator you're supposed to go to do this problem. You're going to go to t-test. So use t-test on TI-83. Step number 4 is then to do that, go to t-test, compute the test statistic and the p-value. So the test statistic, if we're doing a t-test, the test statistic is called t, and I don't care if you use a capital T or a little t, he kind of alternates. And the p-value, so now we're ready to go to the calculator. So push the stat button, go over to test, and it's just the second one down is t-test. Press enter. First thing you have to decide is data or stats. It's stats because they didn't give us the data for all 20 of those boxes. They gave us the summary statistics, so that's stats. So select stats, mu sub 0. I was going to pick on you, and you answered anyway. It's a good idea. 18. What about 18.6?
That's the same.
That's the sample mean. Don't ever put the sample mean at mu sub 0. If, on the exam, if you notice and as you're typing it in that you put the same thing at mu 0 as you did at the sample mean, realize, oh, that can't be right. Those can never be the same. So you have hypothesized value and then the actual value in the data. So that's an 18 for mu 0. Then x bar is 18.6. Sx, sample standard deviation, which they told us was a 2. Sample size, 20 boxes. Now I have to pick the alternative hypothesis. I'm picking between the 3 symbols, a not equal, a greater than, or a less than. Well, you just look here and see what you wrote down, and that's the one you match. So I have a greater than mu 0, and just press calculate. So the t-test statistic is 1.34. The p-value is 0.0978 if I go to 4 places. All right. Now, what do you do next with your p-value? Okay, interpret it. So it's 0.0978. What is that? What is that telling me to do? You know this, Logan?
Fails to reject the null.
Okay, we're either going to reject the null or we're going to fail to reject the null. And when do we reject? If what?
Less than alpha.
If the p-value is less than
The alpha.
the alpha level.
They don't give us an alpha.
They didn't give us an alpha level.
Use 0.05.
So we use 0.05. And that, again, that's my oversight. I made up the problem. And I forgot to say, and I'll do that probably on one of the test questions. I'll forget to say what alpha is. So when in doubt, if it doesn't say, use 0.05. Same thing with confidence intervals. If it doesn't say what confidence level, use 95% confidence. Okay? So if we use alpha equal 0.05, what's the conclusion?
Fail to reject.
This is greater than alpha, so fail to reject. The null hypothesis. That's not the conclusion. You are not done. This is not step 5. This is still part of step 4. Right? So I'll come over here and do step 5. The conclusion is stated in the context of the problem. You need to talk about cereal boxes and weight. Okay? So remember, you always start this sentence with there is sufficient evidence or there is not sufficient evidence. Amy?
Will you repeat what you said about reject the null? If p-value is
Less than alpha.
If it's less than alpha, you reject the null. If it's greater than alpha, you fail to reject the null. Okay? So here we fail to reject the null, so do we have sufficient evidence or do we not have sufficient evidence? We do not. Always talk about the alternative hypothesis in your conclusion. So if you fail to reject the null, then you're saying, well, I don't have sufficient evidence for the alternative. Don't ever talk about the null because you'll end up saying it wrong and getting points on it. It's easier to keep it straight if you just always talk about the alternative. So there is not sufficient evidence to conclude that the mean weight in the boxes is greater than 18. I addressed the alternative by making that statement, greater than 18, because that is my alternative hypothesis. Then I don't have sufficient evidence to conclude that. Here's one that not only will cost you 2 or 3 points, but also it'll make me get mad. Don't say this. There is sufficient evidence to conclude that the null hypothesis is true. Right? You can never say the null is true. Why not?
You can't be sure.
Because you don't know that it's exactly 18. Right? So again, remember, go back to the idea of doing a hypothesis test with a confidence interval. You compute a confidence interval and it contains the number 18, then 18 is plausible, but it's not saying it is 18. It's just saying it might be 18. More,
I think it's kind of what I was going to ask. I was just going to ask if we had rejected the null, would we say there is sufficient evidence to
Yeah,
conclude?
exactly.
Okay.
so this sentence won't change except for the word not. Right? That's, I want it written exactly like that, and you either decide whether to put the word not in there or not. Either there is sufficient evidence or there is not sufficient evidence. And always write out the alternative, and then you'll make the correct conclusion. Okay? Piece of cake. All right. We got about 6 minutes left. Part C says to look up the t-critical value that would have been used in the above confidence interval. Did we do a confidence interval?
Part B.
Part B.
Oh, it's part B. I skipped part B. Okay, then it'd be do a confidence interval, and you would go where to do that? T-interval. Instead of t-test, you go t-interval. And then, does the interval provide sufficient evidence? You're looking to see whether 18 is in that interval or not. Okay? Compare that conclusion to the conclusion in step 5. Did they make the same conclusion? They should, although I wasn't careful and I did a one-tailed test and then go back and do a confidence interval, although the confidence interval probably used a different alpha level. Yeah, 90%. So the confidence interval says to do 90%, whereas here we did 0.95. So then they will match up. But I won't do that to you on the exam. I won't have you do a confidence interval and a hypothesis test unless it's a two-tailed test. Okay, so let's go on and zip through to the next one because I want to make sure we get through this one. Yeah.
On C, I'm confused on C. What's the T critical?
You're just going to grab the T table. So if you flip to the back of your book, which I'll have a Xerox
give
of.
that to us on the
Right.
class? Okay.
If you have a TI-84 with the inverse T function on it, then you can get it right off that. You don't need to mess with the table, but since I'll have the table for you, then you can just use that. Okay? Now this one says, in our MA 140 stat survey conducted earlier in the semester, a total of 65 people who exercised and 101 people who did not were surveyed by students in section C. And this is actually old data, this isn't your semester's data, but among the sample of exercisers, 15.38% said they smoked, while among the sample of non-exercisers, 34.65% said they smoked. Provide a 95% confidence interval for the true difference between exercisers and non-exercisers in the proportion who smoke. What kind of a problem do we got here? Proportions problem. It uses the word proportion. Is it a one sample proportions problem or a two sample proportions problem? Two sample. I got a sample of exercisers and a sample of non-exercisers. Right? Now it's asking for a confidence interval, so I'm ready to go to my cheat sheet and have it tell me what I'm supposed to be doing on my calculator. 2 prop z int. Okay, so let's just go right to that. I'll be covering up the numbers here, so you'll have to remind me of what they are. But I'll go to stat and test, and then down to 2 prop z int. Now, a real common mistake that I actually made in my first class this morning was to hit 2 samp t int instead of 2 prop z int. Right? I just got happy with the 2 sample thing and grabbed that. Just be careful, go slow, and make sure I got the one I'm supposed to get. 2 prop z int. Press enter, and it wants 4 things: x1 in1, x2 in2. So x1, does it give us x1? No, it doesn't. Remember what x1 is? It's number of successes. They don't give us the number of successes, they give us the percent of successes, right? And in this case, success is being a smoker, which seems kind of counterintuitive, but what was that percent? 15.38% of how many? 65, yeah. Right? So x1 is 0.1538 times 65, which is what? Well, it doesn't really matter. You can type that right in here. 0.1538 times 65 and press enter, and it'll give you that. Now, don't just go on because the calculator insists that you enter a whole number. That's not a whole number, so you need to now go back over it and round it. So what does that round to? 10. So go back up and type in 10. Then what's in 1? 65. And x2, oops, x2, again, do the same thing. You've got a percent, so you have to figure out what x2 is. So it's 0.34 something? 65 times 101, which is 34.9965, so I need to round that to 35 out of 101. And then confidence level, what is it?
95.
0.95? Okay, so 0.95. Hit calculate. And there's your confidence interval. I'm going to just do this real quick, just for the for your notes. 101 is 35. Now these have been rounded, right? So I'm going to put approximately, and then you enter those. Now the confidence interval is negative 0.32 to negative 0.065. Right? Now I need to go back to the exam to see what I'm supposed to do next. What does it say? Still part A. Interpret the interval. So let me hear your interpretation.
We are 95% confident that the true difference between exercisers and non-exercisers who smoke is within that interval.
Exactly. Perfect. Okay? The key word I'm looking for there in that interpretation is difference. And she said, in fact, I was so nice when I wrote this problem.
It's the same
It
thing.
says, all you have to do is just copy that right there. Right? That's what it says. We are 95% confident that the true difference, blah, 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 is in that interval.
Can you do that on the test?
I don't know, maybe, maybe not. Do the results of the confidence interval in part A indicate that there is a significant difference between exercisers and non-exercisers? If there's no difference, what would that difference be? Nothing or zero, right? Is 0 in the interval? No. The interval went from a negative number to a negative number. So it excluded 0. So the answer to this is yes, because 0 is excluded. Okay? Then it says do a hypothesis test for the same data showing all 5 steps. So I'm not going to have time to go through all that. In fact, I'm past being out of time. What is the null and alternative hypothesis? P1 minus P2 is 0 versus
About
not equal to 0. How do I know to use not equal to 0? Because it says test to see if there's any difference. It doesn't say test to see if one's bigger than the other one or one's smaller than the other one. It just says is there a difference. So it's a not equal symbol. Then where are you going to go on your calculator? 2 prop z test this time. And all the same values you entered before should still be in there, right? And then you get a p-value, decide whether you're going to reject the null or not. We already know from our confidence interval that we're going to reject the null. So if you don't get a p-value that's less than 0.05, you know, well, I entered something wrong. Because it has to agree. All right, have a good weekend. I will be checking email through the weekend, so if you have questions as you're studying, just email me and I'll get them answered.